morning, guys. Today we're going to be graphing quadratic functions, and really we're going to do more of a sketch of these functions, so let's go ahead and get started. In order to be able to do this, we need to review what the standard form of a quadratic function looks like. In the standard form, it looks like y equals ax squared plus bx plus c, where a, b, and c are numbers. A and b are coefficients because they're in front of the variable x, and c is a constant because it's the number at the end. So we are going to be looking specifically at the value of the letter a, or the number of a, which tells us whether the parabola opens up or opens down. Again, make sure that you're writing this down. Pause the video since I already have everything written. Take a minute to copy it down. And write down anything else that I might say is important, but it's not written down. So learn how to be a good note taker. So the value of a tells us whether the parabola opens up or opens down. Remember, a parabola means that it is U-shaped. That's why it's called a parabola. And a quadratic function is a parabola. So we use that word interchangeably, quadratic and parabola. Keep that in mind. And parabola describes the U-shape. So if a is positive, if the value of a is positive, we know that our graph is opening up. So it looks something like this. It's a U that's opening upwards. And then if our a is negative, we know that the graph opens down. So it looks something like this. So we're going to be looking at the a value. And we're also going to be looking at the value of c, because c gives us the y-intercept of the graph. And remember, this is one of the key things that my students always get confused with, is that the x value equals 0 at the y-intercept. X equals 0 always, because we're at the y-intercept. So our coordinate, because the y-intercept is a coordinate, would be 0 and whatever that value of c is from the equation. C is the constant by itself up in here in the standard form, where we have just c by itself. Okay? And then this is the part that I think is most common in mathematics, is how to find the x-intercepts of the graph. So first, we need to set the function equal to 0. Because if you remember, the x-intercepts are also called zeros. X-intercepts are zeros. So that kind of makes sense because the function has to equal 0. That means y equals 0. It's also called the solutions, and it's also called the roots of the function. So keep that in mind. Finding the x-intercepts, zeros, are the same thing, and y is always 0. So we're going to have to set the function equal to 0. Then we're going to have to factor the function. We're going to use the box method to factor these functions. And then we need to set each factor that we find from the box method equal to 0 and solve to get our x-intercepts. So let's go ahead and jump into the first example. Example number 1. Let's graph this equation. Looking at this equation, I can tell one thing real quick. That the letter a, the value of a, is that number in front of the x squared, ax squared. In this case, my a equals 1. There's an understood 1. And it is positive. So I know, based on that, just by looking at it, that the graph opens up like this. All right? So that's one key thing that I can tell just right off the bat by looking at that equation. Another thing I can tell right off the bat is that my y-intercept is 12. So remember, x is always 0, and then 12 is that value of c. Because this is my c right here, and this is my bx. So my y-intercept is 12. So I know that my graph crosses somewhere up here. I'm putting a point on that graph where it doesn't extend to 12 right here. So we're going to assume that's 12. So right off the bat, I could tell those two things. Now we got to do the x-intercepts. This is where it takes a little bit a longer time. So I'm going to write it over here. I'm going to write my third step. I'm going to have y equals x squared minus 8x plus 12. So again, the first step was to set it equal to 0. So I'm going to say y is 0 because that's how you find your x-intercepts. And then I have to factor this using the box method. Factoring comes into play lots and lots in math, so it's important to be able to do that. So I'm going to put that into my box. And I know this is x squared, this is positive 12, and this is negative 8. And to factor this, I'm looking for two numbers that add to negative 8 and multiply to positive 12. So I like the box method because I know that I got to get x times x to get x squared. And then I need numbers that multiply to 12 and add to 8. I'm thinking 4 and 3. But 4 and 3 do not give me 8, so that did not work. Let's think of another number. 2 and 6. 2 times 6. Let me try that one. 2 and 6. 2 and 6 add to 8 and multiply to 12, but I need a negative 8. So that means that both of these must be negative. So that's a negative 2x, and that's a negative 6x. I have another video using the box methods if you have questions on how that box method works. So make sure to check out the other video. So we're going to have 0 equals, and instead of writing x squared minus 8x plus 12, we're going to write x minus 2 and x minus 6. Now, this is where my students don't understand the next step. But here, I'm using the 0 property because the 0 property states that if one number is 0, it makes the whole expression 0. So for example, if I had 0 times 3, it doesn't matter that that's a 3 because that first 0 is going to make it 0. Or if I had 5 times 0, it wouldn't matter that the 5 is there because the second part is 0, so it makes the answer 0. So that is exactly what I'm applying to this. If I make this factor 0, x minus 2, it's going to make the entire expression 0. Or, this is where you got to think of the other part, or x minus 6. If I make x minus 6 0, it's going to make the entire expression 0. So really, I'm going to have two answers to this. So this is where we set each factor equal to 0. So we say we got to solve for x plus 2 plus 2. X equals 2. And then, so that's my first solution. And then plus 6. Whoops. Give me a second. Got a little ahead of myself. So this is x minus 6, so I got to add 6 to both sides. And then x equals positive 6. So here in this expression, we have two x-intercepts. Two x-intercepts. And they are here when x equals 2, so it's 2, 0, and when x equals 6, 6, 0. These are my two x-intercepts, which these are also called zeros, solutions, and roots. So let's go back to our graph. I'm going to go back to my graph. I know my graph crosses at 2, 6 because that's one of my zeros. And at 6 right here. 2, 0 and 6, 0. I said it wrong. And then I know my graph is opening up, so I'm able to connect it all together. I know that it goes through this 12, and it comes down through here, and then it has to come back up, and it goes there. There is a way to find the vertex. This is just an estimate of the vertex. It's not really the vertex. There is a way to find the vertex, but we're not doing it in this video. So again, this is just kind of a rough sketch looking specifically at the x-intercepts. Here's my x-intercepts. Alright, so you can go ahead and hopefully rewatch the video if you didn't understand something. I'm going to post another one with another example. So make sure that you rewind it. Let me know if you have any questions. Have a good day.